Hello. In this video, what I want to demonstrate is a process that I sometimes do for proof of concepts or prototypes where I need to quickly spin something up to demonstrate something to see how something works. In this case, in this one, the need I have is to be able to demonstrate how AKS workload identity works to peers of mine so that they can get a deep understanding of how you set up workload identity, the configurations that you do in the infrastructure and the YAML of Kubernetes objects and things like that. So uh, what I did is I created a specification around creating a Python script to execute all the actions in a demo style so that somebody can learn. The specification is a very, very detailed, in-depth specification file. It essentially is what you would see typically that you might write a specification um, to tell an engineer what to do, but in great detail with very sort of specifics, not the how, but the what. So we're sort of telling it how we want the interface of the CLI to work. We tell it different resources that we want to create, naming patterns that we want to use. We might talk about um, the the sequence of events of things that we want to create. We here in part two are start to define how we want things to look on the screen of the output of the script that runs. The visualizations of how it outputs is part two. And then the final part down here would be something about how we want to validate it. What's our success criteria? How do we determine whether or not the activity has been completed properly? So this is a very, very complex specification, detailed. It's a complex job and activity. What we're going to do then is we're going to open up and we're going to use one of the probably the easiest or the best way to do code like this right now, which is using Anthropic's Claude 4 along with Claude Code to do the agent work and activities and stuff like that. So I'm just going to enter into Claude. And because this is so complex, really we have about a 90% chance of success without a little bit of things. Oftentimes it gets it exactly right, but there are still times when there are certain errors that might happen that you have to go resolve yourself. So we're going to open up this and we're just going to say something as simple as implement the spec and fire it off and let the agent go to work on this to actually read the specification and create the demo script that'll be required. So it'll create its task list and then it should finish depending upon the backend systems and the models and stuff like that, how long it actually takes to process, but usually a couple minutes or so. Okay, that is completed. We're going to exit. Oh, clear the screen. Now it's up to full screen. And you can see here, now we have our script right here. It's a Python script. And we're gonna run essentially the script. There should be a help command. See the context, which works, that's good. And let's execute the command. And you can see now immediately it's kicked off and it is wrote the entire code base based off of the specification file, like we described. And when I said it was detailed, the idea was we're specifying how we want the output. That since this is educational, I don't want to read me with all this information in it that I have to then copy, paste, and things change. It's a dynamic construction capability. So we'll let this process. While this is processing for a second, we'll shrink this down, and we'll just, for interest's sake, look at the script for a second, and you can sort of see it's a Python UV script, follows the patterns. We had defined the versions and things like that. Uh, AI tends to be very, very good at writing Python, and doesn't look like anything odd in here. It's 735 lines of Python code, so actually not too bad. So we'll let this process and see if we can get a completed state. All right, and there we have it. It's completed. It did work successfully on a one shot. And you can see here, essentially what's happened is we've shown the information from within the pod of the secrets. And all of this was done with workload identity. And now I have a true demo. I could just take this output, parse it again into a simple README, and I could have the same results, or I could go change the style because everything has been sort of put in here as far as to how it works. We can do the same thing. So even though I used Claude for this, it's just a matter of time here. I think it was just today that the Claude 4 has come out. Right now, it's severely throttled at the moment, but my feeling is within a short amount of time, I'll be able to do the exact same activity from within GitHub Copilot. And instead of using Claude Code as the agent to do the activity, we'd be using Copilot agent mode to do the activity. And it would work exactly the same thing, assuming that the model selection was the right model selection. One of the learnings when you do this is each model works differently. So a specification that you write that works great for Claude 4, you might try it with GPT 4.1, and it might not work at all because how the models interact, the things that it knows how to do. So specifications and model selections tend to be sort of not tightly bound, but related based off of the complexity. So hopefully this was a good learning demo, and we got something from this. Thanks for watching.